Hello friends, today I shall be speaking to you about the NISAR satellite. NISAR satellite is a joint project between the NASA and the ISRO. So this is called NASA-ISRO Synthetic Aperture Radar satellite, which has taken 10 years into the making. What's so special about it? It's an Earth satellite, and there are a number of Earth satellites in the orbit today. As on today, there are nearly 11,000 Earth satellites in the sky, out of which more than 170 or 80 are Indian satellites. Earth satellite is a satellite which monitors the Earth. Right? The terrain, it does the terrain mapping, it does the forest, the water bodies, the snow caps, etc., and it monitors that. Fine. And how do they do that? Because they have cameras. Most of them have cameras, which have got depending on the kind of contraptions they use, the clarity of the objects is there. Some of them are synthetic aperture radar satellites. What is an SAR? And what's it say? Cameras, they have the difficulty of visibility at night, difficulty in the bad weather. So they are radar-based satellites called the synthetic aperture radar satellites. They can see through the forest day, night, so they get better efficiency. And there are two kinds of SAR satellites which are there existing as of now. One is an L-band, one is an S-band. Fine. An L-band is a band satellite which can look, which has got a higher frequency and can look deeper at the smaller objects. Can penetrate the tree cover, can penetrate the leaves, can penetrate at a minute level. The S-band, which is the other band, which is of the lower frequency, it can see at a larger macro level, the water bodies, the forest, the crops, fields, etc. These are the two kind of satellites which are existing. Fine. So whereas each one is monitoring one or the other, getting the data synchronized at one place at one time has been an issue, and therefore the difficulties in weather forecasting or the mapping is that much little bit more inefficient. Fine. So this is the first time when NASA and ISRO joined their hand together to do a satellite which has got both L-band and S-band together on one platform. That's what makes it separate. So therefore it allows the satellite to concurrently, to simultaneously monitor the macro and the micro level information, pictures at the ground level in all weathers, day and night. And the platform has got the system to synchronize them together. This is the big achievement. This NISAR satellite has got a antenna which will be deployed in the next 10 days or so, which is nearly 12 meter wide, and it is equivalent to antenna which could be as much as 20 kilometers on the ground. Now, why do we need a satellite? Because the ground antennas cannot become very large because of obvious reasons of deployability, mobility, and they also have a limitation on the visibility, on the distance that they can see because of the fact that horizon comes in the way. Fine, that they have a limitation of horizon because the microwaves travel straight line, and the Earth is round, and therefore the horizons can't let it go very far, and therefore they are ideal to be put from the sky like a satellite. So therefore they are observing a larger area. Fine, so that is the advantage. And when you go up and go to space, you can use a smaller antenna to cover a very large area. So that is exactly what this is done, and this would be generating enough data, nearly 20 terabytes of data per day. It's a huge amount of data of Earth, 24 hours a day, but it takes 3 days or so for it to process data during one cycle. But what is it? See, this is especially significant for disaster management, for warning for that, for climate change issues, and of course mapping, melting of the glaciers, cutting of the forest. So at the minutest level, at the level of a centimeter, can be monitored at one time. So that's a great feat, great achievement, great scientific achievement on part of our scientists. And it has cost nearly $1 billion. Nearly 60% based by the NASA and 40% by India. But India has launched it on our own GSLV rocket and put into orbit. So that's contributing nearly equally. And this data is available for mankind for the issues, of important issues of climate change, for disaster management, for micro level mapping, etc., which is a great achievement. Thank you.